Okay, hi, for the 5 harmony student who missed today's lesson, today 15th of February, the one period lesson, I would like to continue on this second part. Okay, continue on this second part on the uh, of refraction, which is tested in your WA1. Okay, so we'll need you to quickly view this video and learn it on your own because your test is next Monday. So everything in this page here, I'm showing you now, this page here is important. The word example is important for you to cover it and practice again. Okay, cover it and practice again. Every question, there are some tricks, there's something that you have to be careful about. Okay, so yesterday I ended at the calculation of this part A. Okay, we ended at the calculation of this part A here. Yeah, this part A calculation. Given that all this angle, you recall first step number one, identify the refractive uh identify the normal line. Okay, where the normal line is. Then number two, identify uh the incident and the refracted angle. Okay, incident and refracted angle here. Incident angle, okay, between the incident ray and the normal line. Then the refracted angle between the refracted ray and the normal line. Once you identify the angle, the rest are easy already. Okay, once you see where the I and the R is, remember you take sine big angle over the sine small angle. Yeah, sine big angle over sine small angle. Press your calculator, you will get 1.46. Three significant figures answer. Now have a try on this one. Second question. Okay, so let's go through our procedure again. Step number one, identify where the normal line is. So that this is the normal line. Okay, normal line. And step number two, identify where the angle I, angle R is. So where's my angle I? Is it 60? Is it 50 degree? No. Okay. Angle I is between the ray and the normal line. So sometimes angles are given, sometimes it's not. This is angle I. And where's my angle R? Between the normal line and the refracted ray. This is my angle R. So you can tell angle I is not 50. It is 90 minus 50, 40. And angle R is 90 minus 63, 27. Okay. So once you get these two angles correct, the rest is easy. To find refractive index of the glass block, all you have to do is take sine big angle over sine small angle. Sine 40 over sine 27. And you will get, press your calculator, this is what you get, 1.42. Okay, 1.42. We can't do part 2 yet because this part I will not teach you how the ray travel through semicircular glass block. I will not teach you yet. Okay, uh, after your WA1, then we will learn that. Okay, a lot more, just a few more on the calculation also. Uh, so now you see this diagram again, angles are given. Your job this time round, you are given the refractive index. Read the question. The refractive index, okay, wait. The refractive index of the glass block is 1.48. So now 1.48 is given. But you need to calculate angle R. Angle R in the diagram. Let's look at the diagram. Angle R. Refracted angle is here. Again, still you have to identify your normal line so that you can tell who is your incident angle, angle I. Is it the 30 degree or is it the 60 degree? Okay, so between the ray and the normal line, that is my angle I. So my angle I is 60. Now the problem is I don't know my angle R. So just substitute into your formula. All this angle kind of question, you only have sine I over sine R, the formula. So you know, you look at this diagram, this diagram, you should be able to tell that I is the bigger angle. I is 60, R is the smaller angle. So how would you put? Do you put sine 60 over sine R or sine R over sine 60? Remember, it will be big angle on top, small angle below. So it's sine 60 over sine r. Now the next part of the job is bring the unknown up to the left hand side. Unknown, bring up. The known, bring down. Right? The known, bring down. Okay? Unknown, bring up. The known, bring down. Then you'll be able to tell very quickly. Next step, you will see this. Okay? Okay. So sine r, sine 60 over 1.48. Okay, 1.48. And do your inverse sine. Do your inverse sine. Okay, do your inverse sine. 0.585. Right? Sine 60 over 1.48 is 0.585. Let me write that more clearly. 0.585. So to find r, you have to use r equal inverse your sine, right? Inverse your sine 0.585, and then you will get your answer 38 point something, right? Okay, you will get your answer 38 point something degree. Sorry, I don't have a calculator. You press your calculator here. It's 38 point something, okay, degree. Three significant figure. Then check your answer. 38 point something. Is it correct? Your angle R should be smaller than angle I. So 38 is a reasonable answer. It's less than 60. Okay, let's move on to this question now. I have two parts where the light comes from the water out into the air. At point A, there is a refraction. Point B is a refraction. Since both refraction happens from water, and you just need to find out the refractive index of the water from what is given here. You see, you are given the angle A and B at A and B, angles at A and B. Calculate the R. It is the R that you don't know this time. Okay, this R unknown. If you can see here, where I'm writing, R is the unknown. And to find this R, you have to use the formula sine I over sine R, right? But it has to be equal to a refractive index, which you should know, the water. Then you can solve. So how to find this refractive index first? So the job here is, you can try it yourself first. Pause this part and try it yourself. Then see whether the answer is correct or not. Okay. The answer here in the end is, the R is 78.7. Okay. So it has to start all the way from part A. Let's go from A. Who is the angle I? Angle I is the 23. Angle R? Angle R is the 30. Then use the sine R over sine I, the big angle, sine 30 over sine 23, to find your refractive index of the water first. Okay? And here you get 1.28. Now use your 1.28, go to the point B, refraction, to solve your R. Now who should be on top, who should be below? Okay? You will use refractive index N equals to sine R over sine I, right? Because R is the bigger angle. You can tell the light ray is going away from normal line, right? So angle R is the bigger angle compared to the 50-degree I. So now R is the bigger angle. So from B, the equation will look like that. 1.28 refractive index equal to sine R over sine 50, the bigger angle on top. All right. Now with the bigger angle on top, How do you solve this sine I and sine R? Now the unknown is on top. Unknown is on top. So cross multiplication, bring up, bring up. If you bring up, it will be 1.28 times 50, right? 1.28 times 50. Inverse R, solve this part. Inverse R, inverse sine, I mean R equals to inverse sine this answer, you'll get 78.7. So these four examples, A, B, C, D, cover it and try it again. Try it again. You want more practice, you can try it on the worksheet behind. Okay? If we have time later, we go to it. Okay, you may want to try this question. Let me pause here. Okay. Okay, you flip to the worksheet behind. You should be able to see this one. Okay. Have a try on question. Have a try on question 10. If you want to practice your sin I sin R formula. And also question 12. Have a practice on these two. These were the two that we tried in the class today. Okay. So given all the angles, who is the angle I, who is the angle R? Identify first. First of all, identify your normal line. Okay. You can pause the video here and try the question yourself. My job here is to calculate the refractive index of the glass. So obviously the formula has got to be refractive index of the glass equals to sine something over sine something, right? Sine bigger angle over sine smaller angle. But identify your I and R first. So incident angle, incident ray is here. Between the incident ray and normal line, this is my angle I. Between refracted ray and normal line, this is my angle R. So who is the bigger angle? 38. So it's sine 38. Okay, sine 38 degree over sine 25 degree. Press your calculator. Answer must be in 3 significant figure. Okay, I leave that to you. Go and do it yourself. All right. Now, this question 12. We are talking about this interface, where the refraction happen is this interface. Okay, this interface. At B. So at B, let's ignore part A first. Part A, let's not do yet. Okay, it's about the changing direction, but let's ignore that part first. What is the angle of incident, angle I in degree at B? Who is the angle I? So if you can see, this is the incident ray. This is the incident ray coming to point B. So incident angle must be between the ray and the normal line. So 27. Okay. Angle R. Again, refracted ray is here. Between refracted ray and the normal line, 40 degree. Okay. Now calculate your refractive index of the glass. Sine what over sine what? Sine bigger angle 40 over sine 27. Problem solved. Okay. Answer must be in 3 significant figure. Problem solved. How do I know whether the answer is correct? It must be 1 point something one refractive index of glass being heavier than air. It must be 1 point something. If you get 0 point something, you would have, I believe you have put the angle wrongly already. You must have put 27 over 40 instead. Okay, so these were the two questions we solved in the class. Go and try it yourself. Want to try some more? Please work it in your 10-year series. Find in your 10-year series to do. Okay, I go back to your notes now. We have a little bit of diagram drawing left to do, which was this one. So in the class, I was trying to show how the light travel through the triangular glass block, and this one. Okay, how the light go through. Remember, we have practiced in my first video, we have practiced surface that is horizontal, surface that is vertical and surface that are slanted. Now if you look at this triangular prism, we have slanted surface one side, slanted surface the other side. Remember I told you, if you don't like slanted surface, you can always turn your paper until the slanted surface is horizontal right in front of you. So if I look at this diagram A, look at this diagram A, let me quickly demonstrate how it should travel through the glass block. So this will be the glass block. If you orientate your paper, change until this surface become horizontal, then this surface become horizontal. Yeah. Okay. Then now you draw your normal line. Normal line must be perpendicular, right? So this is wrong, right? My normal line. Make sure it's perpendicular. Very important. Normal line must draw correctly. Perpendicular to the surface. Okay. Now ask yourself, the rule comes in already. Light travel from air, less dense, to glass, denser. Less dense to denser. Light ray must bend towards normal line. So original path would be like that. Always ask yourself, this is the original path it would have gone through without the glass block. Without the glass block, it would have gone through straight like that. So the bending will only happen in this quadrant. Okay? This quadrant where the original light beam is. Alright? So remember, light travel from air to glass, bend towards normal line. So bend towards this direction. Okay? Any angle within this sector here. Down here is the original path. Original path is straight like that. Any angle down here is considered towards. So any angle here is okay. So this is how it will be to here. Okay, to this point. So you travel to this point. Now come to this point, it is going to go out into the air. So to go out into the air, what should you do now? Let me wait let me group the all the light ray together, then we can shift. Okay, so now I have to consider this part of the surface. I'm going to make it horizontal again. So this part of the surface, let's turn the other side. Turn the other side. Okay, then become horizontal again. Okay, horizontal to me on the desk when you're drawing. Now again, when it's horizontal, draw your normal line. Let me make it go to the front. Okay, draw your normal line. Is this normal line drawn correctly? No, right? Normal, since this line is like that, normal line must be perpendicular. So it should be this way. Okay, this way. Alright. Then now let's look at the ray. Let's look at the ray. The ray original path must have been, sorry, it keeps jumping up. Original path must would have been like that, right? Original path straight outward. Original path. Okay, original path would have gone straight like that if it didn't have to go through two medium. But now it is going to travel from glass out to the air. Does it bend towards the normal line or bend away from normal line? The answer is bend away from the rule we learned yesterday. It bend away. So bend away is this way. So again, let me uh, uh, let me group the picture. Okay, group it. Now I turn the whole thing back to the triangle again. You will see that the diagram looks like that. Okay, there you go. Okay, the diagram looks like that. Okay, when your paper shift back to the original position, it will look like that. All right. So go back to your picture again. So let's look at this. So normal line, bend towards normal line. Okay, arrow, draw normal line. You must draw normal line, then there's a normal line to compare whether it's towards or away. Let me redraw this normal line. Normal line. Okay. Now light ray come out from glass to the air, bend. Original path was like that. Bend away means bend this side. Okay, bend this way. Bend away from normal line. Okay, so solve. What is the angle I? Is angle I 20 degree? Is it 20 degree? Wrong. Remember, angle I is between the incident ray and the normal line. This is my angle I, which means it's 90 minus 20 equals to 70. Okay, 70. Okay, 70 degree. The degree must put down. Degree is a unit. Okay, now let's look at this triangular prism. The very first line that you can draw confidently, since this object, since it is 90 degree to the surface, remember rule number 1 yesterday? We say, first video clip, rule number 1, when light ray is 90 degree, it will go straight through. It will go straight through, okay, without bending when it's 90 degree to the surface. So 90 degree to the surface, go straight through. Okay, go straight through. But now it meet this surface no longer 90. It wants to go out to the air. You have to think about the rule again. What line must I draw first before I decide how it should travel out? Okay, normal line. Alright, normal line. So let's draw the normal line. Again, if you don't like slanted surface, you can always orientate your paper until this surface is until this surface become horizontal to you. But I'm used to it already. I know normal line looks like that here. Okay, the normal line. So this is my normal line. You should use ruler. I can't. I'm drawing on the screen. I cannot. Okay. Now decide your light ray, how it should travel out into the air. If it go original path, it would have gone straight like that. But no, we are not going to draw this straight path. We know it's going to bend, but bend within this sector only. It will bend within this sector only. Okay. So it shouldn't bend anywhere else. So bending within this sector, let's see, bend glass to air, bend away from normal line. So away, it will look like that. Okay, bend away. All right. So what is my angle I? At X. At X, my angle I here at X, angle I is, remember, 90 degree, I is 0. At 90 degree, I is equal to 0. Then this was what we learned yesterday. Okay. When ray is 90 degree, angle I and angle R is 0 degree. Okay. Explain why the ray did not bend after entering X. Why it did not bend after entering X. Why didn't it bend at this part? Why did it go straight in? Because the ray is perpendicular to the surface. It's perpendicular to the surface. Okay. Or you can say, or angle I is equal to 0 degree. Either one of the answer is acceptable. Now this one I'm going to skip because it's not in the test. Alright. But this one, yes, this one you have to know. So let's finish this last part. Okay. Of the two ray, ray 1 and ray 2, which one is the easiest for you to draw? Ray 1, right? Because ray 1 is 90 degree to the surface. How will it go through this rectangular glass block? It would have gone straight, right? So ray 1, if you have 1 mark to earn, this kind of 1 mark don't waste. Okay, I'm trying to draw as straight as I can because I can't use a ruler. Yeah. Now in your test and exam, you have to use ruler and pencil and draw straight. Any freehand drawing, I repeat, any freehand drawing, you will lose mark. Okay, must be straight. Okay, now the second ray, the angle is given to you 40 and 20. I is 40. So let's write it down. I is 40. Outside here, I is 40. And R between the refracted ray and the normal line is 20 degree. Now what is angle E? Angle E is emergent. After you emerge out from the other side in the air, what is the angle of emergence? So let's complete the diagram first. So if you follow this ray, incomplete ray, you have nowhere to go but to go this way in, right? Okay, all right, up to here. Any question? Because we are just completing the incomplete ray. So you just follow straight. And looking at this ray, yes, from air to glass, it bent towards normal line. You can see towards the angle R is smaller than angle I. But right here, this point, at this point, you have to, before you start drawing ray going out, what ray must you draw? What line must you draw first? The normal line. Okay, so draw the normal line. Okay, draw the normal line. After you draw the normal line, now ask yourself the rule. From glass out to the air, light must bend away. But away at which sector? Remember the original path sector, original path. Original path would have been here. Okay, original path. So it's at which sector? Around here, this sector. Okay, the bending must happen around this sector. So bend away, must bend this side. But be careful when you bend this one, you bend away because AB surface is perpendicular to each other. No, is parallel to each other. AB is parallel to CD surface. Therefore, this ray that you bend out, the emergent ray, we call this the emergent ray. This emergent ray, when we put the ruler straight and project backward, it must also be parallel to the incident ray here. This must happen because these two surfaces AB and CD are parallel. So I repeat, when you draw this emergent ray bending away from normal line, if I put the ruler and extend backward, if I put the ruler back and look backward, it must be parallel. This ruler must be parallel to this incident ray. Okay? Alright? So where is my emergent ray? My emergent ray, wait, there's lag. My laptop emergent ray is here. So if these two rays, this emergent ray and incident ray are parallel, what do you think is the emergent angle? Angle E will be how much? Parallel, it will be also equals to 40 degree. Okay, so angle E is also 40 degree. That's all you have to know for your WA1. So if you browse through, you have learned drawing of diagram to complete refraction, how refraction happen, then draw how light ray emerge through slanted surface like triangular prism, and how it go through a rectangular prism, rectangular glass block. Okay, and of course with all this kind of angle question, you always use sine I over sine R to solve. Always use sine I over sine R. Okay, and the other formula is speed one. Speed formula, you use question that give you speed. Okay, question that give you meter per second, then you use speed formula to solve the refractive index. So you only learn two formulas so far from this topic, part 1. Okay, this topic at part 1. All right, so that's all for your WA1. And for those who missed lesson today, I gave the WA1 practice paper with answer attached. So if you didn't get it today, make sure tomorrow you get a copy from under your desk. Okay, thank you. Any question you have problem you find challenging, you can always WhatsApp me. Or if there's question you want to ask from your WA1 practice paper, you need me to conduct a Zoom over the weekend, let me know a common time where I can invite people who want to ask question to join. Okay? All right. That's all. Thank you.